Hello everybody, this is Cameron Snow with Danomics. So in this video, I'm going to be talking about how we can make synthetic shear logs within Danomics. Now, if you're wondering why this is important, it's because synthetic shear logs and the geomechanical properties that are derived from those are critical to doing things like designing your completions. So if you're drilling horizontal wells that you're going to be fracking and you want to get the most out of those wells, you need to have an optimal frac design, and to get that optimal frac design, you need to understand the geomechanical properties. Danomics can help you do that by generating synthetic shears. So let's take a look at how easy that can be. So first of all, what you'll do is you'll set up a project and you'll choose your key well. In this case, I'm working with some data from the Powder River Basin. And I've gone through and I've just set up my stats window. I've gone through and I've applied Danomics one-click curve normalization to my gamma ray just to help tame that response a little bit across the basin. And then I've gone through and used Danomics automated machine learning methods where I can utilize either multilinear regression or random forest to repair any washouts in my logs. Note that I've also used that same machine learning capabilities to infill any gaps that are in my logs as well. This is especially critical if you're going to be using that shear profile for geophysical applications. So once I've done this and I'm ready to move along to my interpretation, before we do a interpretation of our shear log, I do recommend going through and doing a few of the early pieces of your interpretation. And the reason why we're doing this is because if you want to use, for example, a multi-mineral model to drive your synthetic shear, of course you need to have that multi-mineral model built out and calibrated. So to do that, we would start off by interpreting our clay volume, where we'd apply methods like our V-clay from neutron density and our V-clay from gamma ray, get those calibrated together. We would perform a TOC analysis where we'd calculate our weight percent of TOC, convert that to a volume of kerogen, and we would pass that information all into our mineral inversion, where we could go through and calculate our mineralogies within this area. And now once we have that, now we're ready to move along to our shear log modeling. So we're going to choose our shear log modeling module. And within this module, we have a lot of different methods that are available to you. We've got Danomics blended lithology model, which utilizes the Greenberg and Castagna endpoints to generate a shear log. We've got the Greenberg and Castagna models available. We've got the Brocher models, the Eskandari models, and Carrol's original model from 1969. So we've got a lot of different choices for you here. And in the log plots, we've got a number of templates that are built out that can help you explore your data and decide which model is right for you. And you can set that model on a zone by zone basis. So let's just take a look at some of these tracks. Here we have our original data, our original shear data shown in black, our synthetic shear data shown in red, and our compressional sonic shown here in blue. Here in each of the subsequent tracks, we have several of the synthetic shears that are being generated that are being compared to our actual. And then we have a few QC plots showing our shear log, our synthetic shear versus our actual shear. We have a modeled Poisson's ratio versus our actual Poisson's, and a modeled bulk modulus versus an actual bulk modulus. Now, how simple is it to change out the different model? Well, let's say I wanted to go from a limestone model to a sandstone model that'd be more appropriate here for this area. It's just a matter of switching that. The software will automatically update this. And then if we need to apply some calibration, we have options to apply some scaling and shifting here. And that's it. Now we've got a synthetic shear for this well. What we want to do, of course, is we want to compare how does this synthetic shear compare to our actual shear. We could do that in a cross plot. We can also just do it here in the log plot. And doing it here in the log plot actually highlights a few interesting bits. So for example, down here in the Parkman formation, we have some very odd shear responses where it looks like something is going on. And it's unclear if this is a problem with the log or a problem with the digitization, but it doesn't look realistic. So what we're going to do here is, we compare that to our actual or to our synthetic, and we see that the synthetic actually has a much more believable response through here. Here a little bit deeper, we see a few areas where we have some spikes that are likely not correct or maybe not as believable as we'd like them to be here in our actual. And once again, the synthetic actually does a really nice job of modeling that out and smoothing out some of those potentially errant points. Now, once we've done that, now this is a well where we're calibrated. Let's go to another well where we can take a look at this. So we're going to jump to a different well over here. So we were at this well, now we're moving to a well that's about 8 to 10 kilometers away. This well doesn't have a shear log available, but when we look at it, we can see that we've generated a synthetic shear from top to bottom for this well. And we could, of course, use this synthetic shear to help design our completion over here in this well. So, we get that synthetic shear, then we calculate our geomechanical properties such as Young, bulk, shear modulus, and Poisson's ratio. And we can evaluate where there might be frac barriers in this well, which zones might be more amenable to fracking, and use that to help guide ourselves when we're designing the completion. All right, and that's all there is to calculating a synthetic shear within Danomics. I hope this was interesting for you, and if you'd like to learn more, just reach out to us at sales@danomics.com, and we'll be happy to show you how you could use this workflow in your day-to-day evaluations. Thanks.